So let's first, I guess we start maybe at the, what does the expression kind of look like? And so we have basically, what are we taking in? So we expect to take in a, something like a number, and then there's either like a plus or potentially a minus, and then another number. And then also there's some white space, right? And then potentially, like if somebody was, not careful, they could maybe put some white space at the beginning too, right? So we could have white space, and then we could have a number, and then white space, and then an operator, plus or minus, and then white space, and then a number. So I would think, so given that, I think maybe think about the expression that we're dealing with. There's two different expressions, right? So there's let's say maybe a plus expression, or maybe a minus expression. Yeah, I'll start with that one. And this could probably do this as a struct, right? Mm-hmm. And then the fields there, you can have like a left and a right. And so what does this mean? I guess basically we could have any numbers, any 64-bit numbers, I guess, on the left or the right. And then, so if we see this, we could, take the left and subtract the right. In addition, you might have another expression for plus. We could do the same thing here, but we might want to. There's also like other ways we could represent this stuff. So we could look at maybe think about the whole parent here too. Maybe eventually we're going to have like all different kinds of expressions. So we could build kind of like a parent structure for that, which wouldn't be a struct actually. It could be the sum type. Let's call it parse tree, for example. And that could, so the other way we could model the plus expression is since plus, we don't care necessarily about the order, right? If you switch, left and right, it doesn't matter. You get the same result, right? So we could just have, two associated values, right? Like that. And then the other option is that we have a minus expression. And then if someday we wanted to add like multiplication expression, whatever, you could imagine just keep filling this up with like different kinds of things. And so this could kind of house a lot of different possibilities. But for now, we'll maybe have these two. And then I guess also the other thing we might need is there's potentially two different operators here, so we might need like a symbol. So what are the two symbols we could model as like plus or minus, right? So I think that would be pretty useful too down the line. I'm trying to think if there's any, and then I think that would probably be a good start. We might want to also, we defined an error type, but maybe we'll define another one here. Maybe we'll start off with like one or two errors. Let's see. I'm gonna also put this on there. I think we talked about this last episode, but this will be helpful for us to print out these errors when they happen. Cool, derive, debug. Yeah, that looks right. So like one thing I could imagine happening is maybe they just don't give us any data, right? So we could imagine like unexpected end of input. And I don't know. I mean, maybe we could define a few more. Maybe there's like no maybe like the symbol that you provide is like not one we handle, right? So we could imagine like returning an error where we return the symbol that's like wrong, and that's the associated value that we just talked about. Or maybe there's like, we expect like a number, and then we get a you know, like a letter or something, or you know, emoji maybe. And I think maybe just one more. Maybe there's like just some kind of parse error that happens, right? So we could have it return one of the standard errors, I believe. Is that? Yeah, I think this is one of them. From the standard library, maybe, you know, we're reading or parsing this this number. You know, I think last episode we talked about how you could parse a number from a string, and it uses the type inference, I believe. So, but maybe it doesn't work for some reason. So we could return this guy. I think that will do it. So basically we've got so like our expressions, math expressions, whatever. So we've got a minus, a plus expression, the symbols, and then some errors. All right. So these are gonna be just some building blocks that we'll need as we go through.
I think line 66 there. So
did I get something?
Yeah. So so I think you meant to associate a minus expression with a parse tree constructor here. So you need like a name.
Yeah. You're good. Oh, sorry. Yep.
Nice.
I'll have myself there. All right. Cool. All right. Yeah, so we've got these guys here. So let's start with some input, right? So I think we learned this last episode a little bit, but there's going to be like a new kind of function that we're going to use actually a number of times here. But we can actually read these. So when we call the main function, we can actually read the args in. I think we did this last time with the forgot what we were reading in exactly, but the they were reading in like a file path or something.
Yes, yeah.
So in this case, though, we're going to read in that expression. So the way you do that again is with the args function, and in this case, we're going to grab the first one. And so that's, you know, the actually the zeroth would be the, like, I believe like the run command in this situation. So this would be the
probably
string.
Like program name, yeah,
or maybe program name. So that's cool. And so we can start to use that tool we just learned about, match, for this. So nth will return, actually, I believe, an option, as we see there. So what do we know about that? We can either get a sum or a none. So let's just build this out a little bit. Decide what we're going to put there yet, but if it's none, I would expect that we're basically not going to be able to do much of anything, right? So let's just return an error, and we can use one of our new errors that we just made. And that would be basically that case that we mentioned where there's no, we get like an unexpected end of input. And let's store this in like a parsed. So we imagine here we're going to do the actual like parsing. So how do we do that? So we're going to probably define some more functions here. I feel like I'm, oh yeah, I commented out my comment here. So, okay. So why doesn't it like that again? Is it because, oh, it's because I'm not returning anything here.
Yeah.
Oh yeah. So we learned about, we didn't mention this before, but one thing I learned about recently is you can do kind of a to-do here. I believe this will just return whatever. Still doesn't like this though. I remember this.
Yeah, so now it doesn't know what your T is.
Oh, okay, gotcha.
Yeah, unfortunately.
Okay. Well, I'm gonna just
put something.
Just return a foo here. Okay.
Well, it has to be a okay.
Oh,
Yeah,
good call.
Unfortunately,
Thank you.
yeah.
All right. So now we're good. Maybe.
Mm-hmm.
We just need a semicolon. Okay, cool. And we can actually print this out. And I don't know if we mentioned this, but this is a handy way to print out any kind of basically anything that is debuggable. So
we could also you could fill the okay with string actually from one.
Oh yeah, that's a good call.
Because then you can see what comes through.
We're getting back.
Yeah.
Yeah, let's see if this does anything. So if we go, this is actually another directory here, and if we run this, we should get, let's just give it like 1 + 1. Got a couple warnings, that's okay. But yeah, it's a little bit hard to see here, but we did actually get okay back. But if we give that nothing, then we get the unexpected input.
Right.
Okay.
And so it makes sense for nth to return an option because the user may or may not type an nth argument, right, to the program, right? That's why nth it has this API, right?
Yeah. And I think you remember you mentioning something about this is an iterator, is that right?
That is correct. Yeah, so the like all iterators have nth, I believe, and so all iterators may have 0 through infinite number of items. So it's possible that there isn't an nth, whatever nth being. So they all return some. That's why.
Okay, cool. All right, so we're at this point we're taking in the argument, and we're checking if it's there or not there.
Mm-hmm.
And then printing it out. So now we have to start kind of parsing it. So I'm going to build a function up here to basically parse the input.
Mm-hmm.
And I think what we want is something that it will take a string. str, is it str?
Mm-hmm. Let's see. Mm-hmm. You got it right.
It will take a string and return. And so we're going to start using that result. This is the built-in one, so we're not going to use our silly one that we made. And it can return one of those guys, or our error type. So I don't know if that makes sense, but so it's a function that takes a string and returns a result. And the result, if everything went well, we should get a parse tree. And again, going back, parse tree is that plus or minus and expression. So we could probably use that then to do some math maybe, or print out the result like we want to. Okay, so how does this work? What did we say was going to be in here? Again, it's going to be potentially some white space, a number, white space, operator, white space, number. So let's start parsing. So the first thing probably we need to parse here is the white space. And as you see here, you could put any amount, right? So we probably want another function. This will be a little more interesting. It's going to have kind of a so we're going to do this kind of technique of consuming things in this input until we get to a point where we should stop, and returning the rest, like whatever's left over.
The Pac-Man technique.
Yeah, so kind of chomp through it. So in this case, this function will read any amount of white space One thing you'll notice too is that we're using snake case, which I guess is the kind of standard for Rust. Whereas other languages you might do more like camel case, but I think this is what most. Is it even? Did you say it gives you an error if you don't?
I don't think so. I think it's
Okay.
I think it's valid Rust. It's just not idiomatic Rust, right?
Okay, cool. But yeah, I think you I don't know. Generally, when you try to follow what the community kind of decided, I guess. But okay, so we're gonna do matching again, but this time, so we can get this kind of chars view on the input, and what that is basically kind of gives us like a backing iterator on the string, and I think Eric and Eric telling me about that. It's this similar to Swift too. That a lot of strings are they're not like straight character arrays like they might be in some other languages. There could be these like some of the characters might be multiple characters,
multiple bytes, right?
Multiple bytes,
Right.
And so when you're iterating over it, you want to iterate over like one at a time. So
I believe that the strings in Rust are UTF-8 encoded.
Yeah. So yeah, I remember the exact encoding for that, but I learned that recently. But yeah, anyway, so this is saying basically grab the first one. So that again could be many bytes, but we want to just take that first one, and remember this is nth returns an option. So use sum, and then when you're doing when you're matching, you can actually like specify like a specific value that you want to match against in the associated type. So in this case, I do that. When I get a space, I want to just keep going, right? Keep chomping, as Eric was saying. And we want to then use cool thing where we can slice into the string and basically get rid of that first character because it's white space. We don't care about it, and pass it in. And you see we're passing in this reference, right? So at the end, when we return, we're going to and that. So if we don't hit white space, we hit something else. We just return whatever we got, and that will allow us to have at the end basically the rest of the string returned. So we've gotten rid of the white space essentially.
Right. So I think on line 92, that's officially called the wildcard match.
Oh yeah. We didn't talk about that. Yeah, good call.
Yeah.
So yeah, this will just match anything else.
Yeah. So basically, in this case, anything that is not a sum of space characters.
Yeah. So and it's in so the order matters here. If you put this, I guess first, or I don't know if that would even hope that would maybe give you a compiler. I don't know.
I'm not sure.
But
it's an interesting question. You want to try it?
Yeah, why not? Let's see. Okay. So yeah, this would be bad, right? Because you would just basically just return whatever is passed in without getting rid of the white space. So be careful about that, I guess. But yeah, it doesn't look like it gave an error, at least in this editor. Cool. Okay. So I don't know if that made sense, but we could test this out a little bit if we want. We can maybe, let's see, would this work? Maybe we could do what do we call this again? Readonly. Yeah, okay. I think I'm gonna have to comment out my parse input though.
You can do Toto, right?
Oh yeah. Or do I not need? I don't need that.
Because you have to return it. Yeah.
So this is a.
So that takes a answer and you pass the string. So you just got to put an ampersand. Yeah.
Okay. Not so bad, but not quite. Does not live long enough. That's a new one. Interesting. So why is that? Oh, because it goes out of scope here? Is that why?
Yeah, but right. So
You have to
uh
do like a mutable string up here or something, or
uh so this is like going to be a little bit annoying to get around. So
okay.
maybe you just want to maybe you just want to debug around the read only. Uh
Oh,
yeah.
debug
This
around
is
them.
going to be tricky to do. You probably don't want to do this.
Okay.
Just yeah.
Oh, just like add a line inside the inside here.
Yeah,
You mean? Okay.
exactly. Yeah.
Okay. Okay. And then we'll do string. Let's return that. Debug. We'll debug here. So we'll get 2 lines. We should get like 2 lines printed out, I think. And so there's nothing here. So we actually didn't get in there. But if I pass some, like, let's say 1 plus 1, you can see here in that on that line, which is nice. The thing about this debug is it tells me like the line number.
Yeah, and the expression. It writes the expression
That's
for you.
cool.
Yeah.
And see, we got rid of the white space. So we're moving right along. All right. Cool. I'm going to put this back since we're eventually going to call our parse input. I guess we could now, but I think that would cause, I'm just not going to leave it right now. Okay. And then, all right. So we've got that. I guess the next piece would be probably need to be able to read a number. Yeah, I would say that's a decent thing to do. So let's do that. Reading a number is pretty straightforward as well. In this case, though, so we're going to take our string in again. And this is probably something we'd call after we do the white space removal. And so this is going to be a kind of a little more complicated result type that we're going to return. It's going to be basically a number. We're going to return the number that we parse, and then the rest of the string. And let's see. Cool.
Looks good.
Yeah. So how do we do that again? We can use our chars iterator again.
So before you go on, you might want to explain what that tuple is there, because this is the first time we talked about this. Yeah.
Yeah, I don't think we have introduced those.
Yeah.
I mean, you kind of saw it a little bit here,
right?
But it's not quite the same thing, I guess.
Yeah.
Yeah. So this is basically like think of it kind of like the same thing as the product type or the struct, but it just doesn't have any names for the types. So
right.
Just basically we're saying we're going to return a string or an I64 and a string in that order together as the results. You should expect to see both of those when there's the result.
Right.
If there's an error, and then you get the error. So
some people do call this the anonymous product type.
Oh, there you go.
Yeah.
Fancy. Okay. But let's start by getting that iterator again. Like that. And we'll also have another mutable variable here for the number of bytes. So the reason we want that is to figure out like how many bytes of this string are a number. And so we're like reading through the beginning until we hit something that's until we decide we need to stop, essentially. And the other cool thing about this part is we're gonna introduce a few new like control structures, as well as do some more kind of advanced pattern matching here. So the first one is we're just gonna loop over the whole string, right? So we want to, again, consume until we, hit the end. Whereas up here, we were kind of doing this recursive thing to get that done. So in this one, now we match, and then we use the next operator on the chars iterator. And so here we can kind of go through our cases. And one thing, I don't know if we didn't actually show this, but we probably want to allow negative numbers as well. So we could expect to see like a dash at the beginning. So I think that's the first thing we'd probably expect to see potentially. So let's handle that case first. And we'd say, and so this is what I was talking about, the more advanced pattern matching. You can actually take other factors into account when you're matching the pattern. So not only do I want this first character or this next character to be a dash, but also I want to say if the bytes read are 0, then we're gonna basically increment. We're gonna read another byte here for our that we'll eventually parse out after this is done. Okay, so that would be the first case. There's a dash initially. The next case could be any other character. So probably, but probably it should be if it's a digit, right? So basically, if we see a dash, then digits, I think we're still in good shape. So these kind of like happy path. And again, we can increment our bytes. Then we want to do, if we hit a space, let's say, right? We can break out of that loop. And that's breaking out of this loop up here, right? So we'll keep looping until we hit maybe this case. I'd say if we hit some other character, though, if you remember earlier, we made this cool error type where, so we're looking for a number, right? So if we hit something else, that's probably not a number char. So we can return that sucker. And so this would just bail out of the whole thing. Not quite, actually, because I'd have to return it.
Right. And so one thing...
Oh, go ahead.
One thing that's probably, I just want to be very clear about is, in Rust, the last expression of a function is always what we return. You don't need to say return. But if you want to early return, anytime you see the return keyword, you're actually bailing out of the entire function. So we're not bailing out of this match. We're not bailing out of the loop. We're actually bailing out of read number, and we're just stopping immediately and returning an error.
Cool. All right. So I think there's just a few more cases here. So we could have nothing. And if bytes read is 0 in that case, that means we got that. I think we have counted this before, but unexpected end of input. And a comma, and then none. So just if it's any other number of bytes read and we get none, we would break out of that loop, so we don't loop forever. Yeah, I would say that's most of the cases. I don't think I missed any. So now we'll, at this point, I would expect we've either returned out of here because we got some error, or we have this bytes read filled it up to how many bytes we want to read essentially off this number, and then parse that. And so one thing we can do here is use that slice operator again and go tell bytes read and parse it. I think we showed this again. I think I mentioned that when we showed this last episode. But we have to know also what to do if it doesn't parse. We want to return a result here.
So maybe we actually want to write this out with a match, because this is yeah.
Oh yeah, I think we talked about that. Yeah. So yeah, we could do match. So parse should return, I believe, a result, or I'm trying to remember. So that means we get either okay and some, I guess it's the number, right? And then what do we do with that? And then or error and some error. All right. So in this case, we would do, what would we do? We would just return the number, right? But in this case, we would return probably.
That looks normal to me.
Yeah, and then we'd return some kind of, yeah, this is not a number. You made this. We talked about this. Number parser. So, and then that could be, it doesn't like that. Let's see.
So I think it requires a
type. Oh yeah, wait, we have that though, right?
Exactly.
Yeah. Do we need like the, okay. Ooh, it's happy. How unusual. Okay. All right, so we got a number now. And really, and just to be clear, if this isn't clear, we're matching on the parse of the input up to the number of bytes that we read. We only read bytes when we got either a dash first, and then and then digits after that, and then we break when we hit the white space. That breaks out of this loop and then gets, yeah. All right, I think everybody is following that, hopefully, and then we can, do that kind of, what do we call? Kind of consume the piece of the string that we don't need anymore, and we're done at that point with this function, anyway. Okay, so far we've gotten white space and numbers. So I think the only other thing we need to be able to read is symbols.
Yeah, I think
right.
That's it. Just gotta.
Do you want to try this out, or do you trust me on this?
I trust.
We can try it out.
Yeah, let's try it out though.
Okay, so yeah, so now that we finished this read number thing, let's just test it out real quick. We'll pass it like a -4 and maybe a like a regular 4. And if we run that, I think we'll get what we expect. Yeah, look at that. Okay, so you can see the expressions there. All right, back to task at hand. All right, I am gonna now, I think the next piece is basically to read a symbol. And that is pretty darn simple compared to the other ones anyway, I think. Given what we know, you can probably guess what we're gonna return here. And remember, we defined a symbol type earlier, so we can return that. And then the rest of the string. And then either an error. All right, so that's our result type again. And then the strings coming in, the result type's coming out. So we are gonna match our input chars and 0 sum. So what's one symbol we could match? Anybody know?
It's a plus.
Oh, you got it. Good work. So if we get that, we
hire this man quick.
We return the plus symbol, and then if we get a minus, return the minus. And what if it's anything else? Well, we've already accounted for that too. So we can just return an error, not a symbol. Hey, look at my autocomplete. And then we return that character that is not a symbol. And then just none again for completeness. And then we just didn't get we didn't like give a complete expression in this case. So we'll just return that. Nice trailing comma, semicolon, and symbol. And all right. Boom.
Nailed it.
All right. Could we actually, yeah, I think you can just do this up here, right? And just do mess with that thing again. Debug, read symbol, and minus. Let's get some cool stuff. Plus, all right. Lots of debugging. Didn't like
that. So character literals you need double quotes.
Ooh, okay. Learning new stuff.
It's the same, yeah. So it can't print symbol.
Oh,
yeah.
Okay.
Yeah.
We could fix that, right?
We can fix that, yeah.
That one's not so bad. So we'll use our handy dandy thingy. Arrive debug. Except I still have stuff.
Yeah, so now you
I'm just not using double quotes. Okay.
Yeah. So double strings, single territory, yeah.
I'm sorry.
Tier.
Okay.
All right, now we're cooking with oil.
Minus, plus, and unexpected. Okay, that's almost every case.
We handled it.
All right. Fun stuff. Okay, we can read a symbol. We can read white space. We can read numbers. This is great. So really, we just have to kind of put it all together. So that can be the parse. So we'll start with, again, this could have some white space at the beginning. So on the left side, if it's trimmed, read any amount of white space, input. Except I didn't call the right function, so that is a problem. All right, there we go. Cool. And then we're gonna get remember our result is so we're gonna read the number next, right? And that number function returns when it's a result, we'll return a symbol untrimmed. And so that's basically the rest of the string. So if we match on read number, and this is left trimmed now. Am I right?
Mm-hmm.
And this is getting like, we all know what's going to happen now. We do OK. We get some values, return those values. Or error, return an error. Let's call this actually, left is not a great variable name. Let's say left number. Okay. So that is I didn't realize that was open. Sorry. So that's the number. And then we can get the symbol at this point, or but we also have white space there, right? So let's get rid of the white space first. Symbol trimmed. Read any amount of white space. What is white space? Okay. Not input, but symbol untrimmed. We'll get autocomplete for that, huh? And then let's get the symbol out. And this is, again, similar to what we see with this function returns a symbol, and then the rest of the we'll call it the right side untrimmed. And that is we're gonna do something a little different here. I think I can't remember if we've shown it yet. But this is like, so, I mean, we've been doing this like all over the place, right? Where we match and it's like either a okay or an error. So we use this result type everywhere.
Yeah, we did it on line 134 there. I think we did it up in the on line 115 there, right?
So, I mean, a lot of times there's like a nice shorthand you can use where we essentially get this kind of stuff for free, I believe. So I don't know if that's the right way to describe it, but the compiler will essentially put that code in for us if we just put this question mark here. Right. And this is kind of like I guess we would say like unwrapping the result, sort of.
Right. Yeah. So this is officially, I think it's a macro, right? So what that basically means is at compile time, the compiler comes through and recognizes that, oh, you put a question mark here, and it will basically expand that to exactly the same code that you wrote on line 134. And this just saves you just like a ton of boilerplate.
Yeah. So now I am just trimming that last right side. And then I'm gonna pull out the last number. And that is a right number. And another new thing we can do here is, at this point, we don't care what's like past the other number. I mean, there probably shouldn't be anything there, but you know, we could just ignore it in this simplified program. So we can essentially use this kind of underscore to denote
wildcard.
Yeah, wildcard. Oh, okay. Yeah, we mentioned that earlier. All right, and it's just saying.
So you have to lift that out of your.
Oh yeah. My bad. Same thing again.
And so you can see that the line 143 and 134 are exactly the same. It's just one uses the question mark.
Gotcha. Cool. All right, we got all the stuff now. So that's pretty cool. So I think basically we're going to build our parse tree at this point. We have enough information to do that. And the way we can do that is by matching on the symbol, right? So we expect that it's either a plus or a minus, right? That's what our function returns. So if it's a plus, that one we made pretty easy to construct. You just put the left number and the right number and return it. And then the minus is a little more complicated, but not too bad either. Say minus expression. Minus expression. expression, and then that takes a left number and a right number, and we'll just make a new line, and then we return a parse tree minus expression that takes the minus expression in. Are we good except for a semicolon, maybe? Yeah. And then finally, a tree. All right, that's our parse input. And now it's happy. So we can actually use that to parse the string. Except it needs to be that kind, maybe. And this doesn't implement the derived debug, which is probably, yeah, we probably want to do something about that. Let's see, could we?
Yeah,
it might be a bit of work.
You just,
I think I might.
There's only two. I think there's two you got to put up there.
Okay. All right, we can do that. So we put it on here. Here.
Yeah, I think that's all you need.
Something's messed up though. I see one error. No? Maybe that's not an error. I think we're okay. Let's give it a shot. Let's see if this will tell me if there's a really an error. Oh, okay. Okay, tree. Oh, yep. That's typical of me. Okay.
Getting murdered.
Oh, look at that. My goodness. It's a plus expression.
So one thing I have noticed is we do have two layers of okay here, because parse returns an okay, and then you put that in an okay, which is totally valid, but probably not useful, right?
Yeah, did we...
That's all the way at the bottom in the main. Line 182.
Oh, I just didn't need that. Yeah. My bad. Good call, though. Hey, that's better. Okay. I think. Yeah. All right. I think there's only like one more thing we want to do here, because this is pretty close, right?
Yeah.
I think our other program would just print out the result.
Yeah.
So
got to interpret.
Yep. So let's just do a quick kind of like do pattern matching kind of on the result. And capital string. So that's what we're going to try to print out. And parse tree. And so this can either be a plus expression, and if it's a plus expression, it has a left and a right. I mean, at this point, this stuff should be pretty familiar, right? I mean, this is basically the same, kind of the same patterns we've been following. So this we'd print out plus, and then the equals, and then the result. And so it's left, right, and then left plus left plus right. Make this look a little prettier, maybe. Yeah, do I? I guess it's probably okay. Yeah, it doesn't look good. All right. And then the other one could be minus, or no, parse tree minus. And then that gives us a struct. Is it a struct? I think it was a struct. With the two left and right. And This one. Yeah, this one. All right. We can do. We say info dot left, info dot right, and then info dot left minus info dot right, and that's pretty nice. Except
variable name, yeah.
Look at that. Would you look at that? All right. All right, cool. So this should return some nice stuff. And this could return. Oh, yeah. Okay. So yeah, here actually we did return a result, right? So we probably have to do our kind of, we could actually just do, could we do the shorthand here? Maybe not. Maybe we want to do, maybe we don't want to do that. So we'll do the match on the parsed again. And let's see, print it out. And we'll print out a cool little printed result and take in our parsed, or not a parsed. Is that parsed? Yeah, I guess that's the, yeah.
Looks good.
That's the parse tree, I guess, right? This is really the tree. Yeah. And then the error, the print line. So we'll print a standard error. Yeah, prints the standard error line. Something went wrong. This is kind of a cool formatting thing, I guess, for results. Is that right?
I think this is the
or for errors
debug placeholder.
Oh, okay.
So you're saying print the debug version, and since you derived debug, it should work.
Cool. All right. So this is looking pretty good.
I guess you called the function something else.
Did I? Print result. Oh. Yeah, it's printed because we're not actually printing it, so it sounds better. All right. I think that's it, man.
I think that's it too.
We're gonna get 2.
Whoa!
Exciting times. So I guess what did we do? I mean, we basically made we went through these product types, sum types. We looked at how we could use them in this kind of, somewhat complicated but somewhat simplistic program to read in simple math expression and then print the result of that.
Right.
We use those. Those are so they're pretty cool tools we can use to build the Rust programs.
Right.
And I don't know, Eric, you want to talk a bit about your what you've done with
That's exactly what
QLC.
I was going to bring up.
I've got it here actually. If you want to talk about it a little bit.
Yeah, so we remember that, back in episode 1 we talked about where we want to go with all this, right? We're starting very small. We're just learning about the features of Rust and how you are effective in Rust, sort of one small part of the programming language at a time. And as Noah talked about, at length, right? Algebraic data types are how you model data in Rust, and they're used for everything, including but not limited to error handling, right? We saw the result type. There are no exceptions in Rust. It's all done using sum types, right? And sort of propagating these errors up. Things like the question mark macro, all this stuff is going to become very sort of your bread and butter if you want to work with Rust programs, especially Rust programs that are fault tolerant, right? And so we talked about how these algebraic data types give you safety in your program, not just from a memory safety standpoint, but also just sort of a business logic or sort of high level integrity of your program, right? In our program, we constructed minus expressions and plus expressions and nothing else. And they both had a left and a right. And it's not actually possible to make an expression without all of those pieces. So, we are sort of building these features up one by one. We're learning about them, and we want to write a more complex compiler, right? And so the thing we wrote today actually is more of an interpreter than a compiler, but the first part of a compiler is parsing, right? Whether you're doing an interpreter or a compiler. And parsing, turns out, is like really well suited for algebraic data types, right? And so this is just one piece of code in the QLC code base, but this is a more complex problem, but we can actually see, if you scroll down, maybe we can find an example somewhere.
Yeah, I wasn't sure if this is the one you wanted to see, but this...
Yeah, like there's all kinds of stuff. Like maybe... yeah, like maybe something a little bit more parsey feel, right?
We go a different file?
Yeah, let's try a different file.
Okay.
Let's try mod, maybe. It's okay, it doesn't matter.
Oh, yeah, mod. That, yeah.
Maybe that'll be okay. Okay, so here's an example on line 65, right? So we're parsing GraphQL expressions, GraphQL strings, and GraphQL strings only come in two forms. They're either an operation or they're a fragment. And then that operation def and that operation fragment def, that operation def and that fragment def there on line 65 and 66, that's going to have all the information we need about an operation and all the information we need about a fragment, and nothing more and nothing less. And those two functions on the left, the from operation, from fragment, on those arms there, they are specifically tuned to handle a fragment or an operation, and they know that a fragment or an operation is correct by construction because the parser has created it for them, right? So this is something that we will definitely see. Well, never ending, right? In programming, data is like everything, right? So if you're going to write programs in Rust, this is how you do it.
Cool.
Yeah.
All right, man. I think that wraps it up.
I think it does too.
We'll probably have another episode next week or something.
Yeah, so I'm going to be out of town next week.
Or the next week.
So we'll have to find some time. But nonetheless, thank you for watching. You can always reach out to us on Twitter. I know Noah's on Twitter. For me, I'm only on GitHub, so you're going to have to, leave a PR. Leave a PR if you have a question. But, or you can also leave comments in the YouTube channel. We'll try to answer them as we see. Anything else to add before we wrap up, Noah?
No, that's it. Just thanks for watching.
All right. We'll see you in the next one.